So in this video, we're going to be looking at velocity in mechanisms using this question. Okay, so we're going to be considering this question to explain the concept of velocity in mechanisms. Now the question says, in a 4-bar chain ABCD, AD is fixed and is 150 millimeter long. The crank AB is 40 millimeter long and rotates at 120 rpm clockwise, while link CD is 80 millimeter long and oscillates about D. BC and AD are of equal length. Find the angular velocity of link CD when angle BAD equals 60 degrees. Okay, so this is a 4-bar mechanism given to us here. So our first task will be to first of all draw this link using some suitable scale, right? Now we were given that link A to D is fixed and the length is 150 millimeter. So we can't really draw 150 millimeter because this is too long. So we're going to be considering a scale that reduces each of these dimensions by at least half. So we'll simply say 1 millimeter is equivalent to 0.5 centimeter, just to be able to break each of these or divide each of these distances by 2. So this is the scale we're using. So that simply means for here that is 150 millimeter, you're going to have 150 millimeter will be equivalent to what? X. Let's find the value. So simply cross multiply. X multiplies this. You have X times 1, which remains X. And that's going to be equal to 150 multiplies 0.5. This is going to give us 75 um, um, 75 centimeter. Okay, so that simply means that we are going to be dividing all the sides by 2. If you apply the same principle here, 80 times 0.5 gives us this link. So basically, we are taking AD to be equal to 75 millimeter. So we are simply dividing each side by 2. Again, D or AB itself is going to be, this is 40 millimeters. So if you divide by 2, you have it to be 20 millimeter. BC is also 150. So BC is now going to be 75 millimeter, and CD is going to be 80 divided by 2, that is 40 millimeter. So this is the scale we are using, 1 millimeter equivalent to 0.5 centimeter. So our first task is to plot this diagram using these scales now. So we have to draw A to D, which is 75 millimeter. So you pick out your meter rule and you draw A to D, 75 millimeter now. So for your meter rule, this is 1, 2, 3, 4, 5, 6, 7. 75 is just at the middle, directly at the middle. So you draw, okay, you trace out 75. So this is link, that's link A to D. So we've gotten A to D. So this is point D and this is point A. Now, if you observe in the question, it was stated that angle A is 60 degrees, so which means AB is inclined at 60 degrees. So that means you're going to be needing your compass, which means you're going to be needing your compass. So you pick out your compass and you measure out angle of 60 degrees. So from your compass, this is 90, this is 70, this is 60 degrees. So simply place your compass and ensure proper alliance with the line. Okay. So with your compass, this is 90 degrees, this is 80 degrees, this is 70, and this is 60 degrees just by here. So you pin here and you draw faint line. Since you've not taken measurement yet, you simply draw faint line. Okay, just draw faint line and join these points together. Okay, so you simply draw faint lines since you've not taken measurements yet, right? All right, so you have this now. A to B, A to B is 40, which is now going to be 20 millimeter by our scaling. So 20 millimeter is simply what? 2, from 1 to 2, that's 20 millimeter, which is 2 centimeter then. Okay, so you place and you measure out 2 centimeter. Okay, this is 2 centimeter, and you draw with a thick line joining A to B. You have this. So that's 2 centimeter. So this is now point B. This is point B, and the angle here is 60 degrees. Now, the next thing we need to do is we want to find point C from the diagram. We want to find point C so we can be able to join B and D together at point C. Since we are not given any angle, the only way to do this is by, first of all, you measure this length 150 millimeter, which is now going to be what? 75. Measure length B to C. That's going to be 75. So you use your protractor in this case. Now you're making use of your protractor. Okay. You use your protractor and you measure out 75 millimeter with your meter rule, and you measure out 75 centimeter with your meter rule. So here is the meter rule. 75 centimeter is definitely going to be, this is 1 2 3 4 5 6 7. 75 is at the middle, which is this. So you pick out this. All right, so you have that. Now you place it at point B. Place that at point B, and you form an arc. You simply form an arc. You simply form an arc. Now, from the length from point B, the length from point B to point C is 80 millimeter, which by scaling we obtain to be what? 40. Simply dividing 80 by 2. So you measure 40 millimeter, still using your protractor. You measure out 40 millimeter and pin at point D. Then you bisect this arc you've created. Okay. So now we have to measure 40 centimeter, rather 40 centimeter. So 40 centimeter is simply, this is 1 2 3 4. So this is 40 centimeter. So you measure out 40 centimeter and you have this. Okay. So you place now at point D. You place this at point D and you bisect once more with a faint line. You bisect. Now the point of intersection of these two, you join them together. So this is the point of intersection here. So you join this point to point D and you have this. Similarly, from the point of intersection, you join that to point B and you have this. So this is your first task, being able to reproduce the given diagram. So we've now been able to reproduce this given diagram. Now we are asked in the question, we are asked to find the angular velocity of length CD. So we are to find the angular velocity of length C to D. Not forgetting, these are the fixed points, and you have this. So we need to find the angular velocity of length C to D, but you cannot do this without a known velocity. So if you take a look at the question once more, they said that the crank AB is 40 millimeter long and rotates at 120 rpm clockwise. So it was also indicated here clockwise. So this arm AB is making a rotation of 120 rpm. So the speed of rotation of AB, NAB was given as 120 rpm. So if this is known, it means you can find the angular speed of AB by formula. Angular speed is given as 2 pi NAB all over 60. So this is actually 2 times pi is 3.142 times NAB was given there as 120 rpm divided by 60. So with this now, this simply implies that the angular speed of AB is going to be equal to, so let's find 2 pi times 120 divided by 60. That simply gives us 12.57. This is 12.57 in radian per seconds. This is the angular speed of arm AB. Therefore, to find the linear speed of that arm AB, VAB is given simply as angular speed of arm AB multiplied by the distance of arm AB. And that distance was given in the original question as 40 millimeter. From A to B is 40 millimeter. So therefore, the speed of rotation of AB is now going to be 12.57 multiplied 40 millimeter is 0.04. Simply 40 divided by 1000, that converts it to meter. So this simply implies that the speed of arm AB is going to be equal to, so this 12.57 multiply 0.04, that simply gives us 0.50. So you have 0.503 in meters per second. So this becomes the speed of arm AB, and this speed is always going to be at 90 degrees to point B. So this speed will be at 90 degrees to point B. So it will be pointing in a direction of motion. Please, that's very important. Now, this arm is moving clockwise, so which means it's going in this direction. So we'll have that speed to be in the direction of motion, and it must be at 90 degrees to that link AB. So you have something like this. It must be at 90 degrees to that link AB, and it will be in the same direction as the direction of motion. Now you know this velocity. After plotting this diagram and you know at least one velocity, it can be easy for you to find the velocity of the other sides. How do you do that? Again, you have to take a simple scale. This velocity here is 0.503, which means it is a very small velocity, right? You can't draw this with your meter rule. It will be very small. It will be a very small dimension. So you simply increase or take a scale that will increase the speed. So you simply take a scale that will improve this velocity, because we need to now draw a velocity diagram, and it is from the diagram we can be able to find the velocity of the other links, right? So you simply take a scale of a scale that will increase this velocity. So you can simply say let 1 centimeter be equal to, or let 1 centimeter be equal to 0.1 meters per second. Therefore, how many centimeter x will be equal to 0.503 meters per second? Because this is what we just obtained here, 0.503 meters per second. So if you do that, you find out that x is going to be equal to, when you cross multiply, 0.503 multiplies 1 and x multiplies 0.1. So you simply have x multiplying 0.1, that's 0.1 x equals 0.503 multiplies 1. So in order to make x subject, you're simply going to have 0.503 divides 0.1, and this is going to be equal to 0.503 divided 0.1. That simply gives us 5.03. So our velocity now is going to be 5.03 meters per second. So not forgetting, this is the scale we are using. 1 centimeter is equivalent to 0.1 meters per second. Therefore, 0.503 meters per second should be equal to what? 5.03 centimeter, please. That will be 5.03 centimeter. Okay, that will be 5.03 centimeter. So that's the scale we are using. So you plot your velocity diagram. Remember that point A to point D is fixed. So you just draw a line to indicate the fixed point. Just a dotted point, sorry. Just put a dot to indicate the fixed point. And these fixed points are A to D. So you use a small letter now to indicate A, comma, D. So that point represents the fixed points. Okay. So you remember now that you have a velocity that is known from A to B, and it is measured at 90 degrees downward. So from this point also, you have to now measure. We are now taking our velocity, remember, to be equal to 5.03. So this is equivalent to 5.03 centimeter. So we are going to be measuring this out now with our meter rule. So you measure out 5.03 because that velocity is known. Velocity at point B is known, and it is 5.03 by our scaling. So you keep your ruler from this point and you measure out. It must also be at 90 degrees and downwards, okay, as can be seen here. So you measure at 90 degrees downwards, you measure at 5.03. Okay, so this is 1 2 3 4 5 5.1. So 5.03 should be somewhere just after, a little bit after 5. So you draw, and that is a known velocity. Now this is now from point A, which is a fixed point, to point B. So that means you have this to be a velocity from point A to point B. So which means this point is point B. You indicate that point with a small letter, that is point B. And of course, this velocity is known. We have it to be 5.03 meter per second or centimeter according to the scaling, since we are using a meter rule. Okay, now having obtained this, the next thing now is from point B to point C, you draw perpendicular line. The speed always must be at 90 degrees to each of the link. So perpendicular to that point from B to point C is this. It must be at 90 degrees to this link, B to C. So this is point B. So at 90 degrees to point B to C, this is how it looks. This is 90 degrees, as can be seen. So this is 90 degrees. So which means you simply move your meter rule to point B. At 90 degrees, you have it here. This is point B. So 90 degrees, you draw with a very faint line. Since we don't know dimensions, just simply draw with a faint line and you have something like this. We don't know each dimension. You can simply draw that with a faint line. Later, you can join them up before knowing their accurate dimensions. Now, after from B to C, the next is from D to C, and from D to C must also be at 90 degrees. The speed must be at 90 degrees. So this is D to C, and this is 90 degrees along DC. Okay, since point D is fixed, so you have 90 degrees along DC. And if you observe, you can also do that here. This is 90 degrees. This is 90 degrees along this arm. So simply join these 2 points together. So if you draw from here now, you can draw with a thick line. You can get this. Okay, and you can finally get this dimension from point B. You can now join this line with a very thick line. You can now join this point with a thick line, and you have this. So not forgetting, this is point B, then from point B down to point C. So from point B, which means this is point C, and this is from D to point C. So the velocity here is from D to point C. Since point D is a fixed point, so this is velocity from D to point C, and that can be labeled as VDC. VDC. So this is our velocity diagram now. All right, so the question says we should find the angular speed or the angular velocity of link CD, and this is link C to D. Okay, so which is, in order to find the angular velocity of link C to D, we have to first of all find the velocity from point C to D. So simply you use your protractor. You can easily use your meter rule as well, but I prefer to use the protractor because it's quite easier for me. So use your protractor and you measure out total distance from point C to point D, which is here. So once you get this, you now place on the meter rule. You place it on the meter rule. So when you place it on the meter rule, you measure now. So this is this from 1. So this is around 3.8. This is around 3.8. Okay, so that's around 3.8. So this simply means that the velocity along CD, VCD or VDC, is equal to 3.8 meters per second. But You recall we took a scale earlier, and we simply said let 1 centimeter be equivalent to 0.1 meters per second. So if we apply that scale, if 1 centimeter is equal to 0.1 meters per second, then in order to obtain velocity at CD, we simply multiply this by what? 0.1. Since earlier we had to divide velocity along AB by 0.1 to obtain 5.03 meter per second. So in this case now we simply multiply to bring it back to the normal value. So multiply this by 0.1. So this simply implies that velocity along DC is equal to 3.8 multiplied 0.1, which simply implies that VDC is going to be equal to 0.38 meters per second. So this becomes the velocity along D to C. So if you know this velocity now, the question is asking us to find the angular speed. So you remember your formula? Angular speed along DC is going to be okay, so simply recall that velocity first of all along CD is simply angular speed along CD multiplied by distance between C to D. So which means you can make angular speed subject, it becomes linear velocity divided by that distance. So angular speed is simply the velocity along CD divided by the distance between C to D. So this is equal to velocity along CD. We obtain the value to be this 0.38. So this is 0.38 divided by distance between C to D. From C to D was given in the question as 80 millimeter. Okay, so let me pull the original question. So from C to D was given in the question as 80 millimeter. So convert this to meter, simply dividing 80 by 1000, that's 0.08. So divide by 0.08. So this simply implies that our angular speed, along DC is going to now be equal to, so simply 0.38 divides 0.08. That simply gives us 4.75 radian per second. So we have 4.75 radian per second, and that becomes the angular speed of that arm. So this is how to use the velocity diagram to determine velocity of any link. In this case, you can also find velocity of from B to C. This is going to now be velocity of C. So this is going to be VC, okay, or VB to C. So you can also take the measurement from here to this point using your meter rule or simply using your protractor, and you will have the same result. Okay, you can simply measure total distance from here to this point. That becomes velocity along that arm. All right, guys, so that's it for this question. In the next video, we're going to be looking into a more complex structure or a more complex mechanism, and employing everything we know here to determine velocity of each of the link. I hope to see you in that video. Thanks.